Dear students, in this video, we are going to discuss how the reflection of light takes place. We have already learned that the light takes reflection when there is a source of light, there is a reflecting surface, and after the reflection there must be some source. So these are the basic requirement that the reflection of light takes place. We have also learned about that when light falls on a polished or a shiny surface, it changes its direction. This is called the reflection of light. We have also learned about that what is the first law of reflection. What is the first law of reflection? When light is incidence on a reflecting surface, like it shows in figure 2, that when there is a light and light is incidence on a reflecting surface, then it reflects back by the same angle. That means if you are taking an angle, that means this angle and this angle is called angle of incidence, which is represented by angle I, and this angle is represented by angle R. This is called angle of incidence and this is called the angle of reflection. As it is mentioned here is also angle of incidence and angle of reflection. So what is the first law of reflection suggests to us? The first law of reflection suggests to us that the angle of incidence is equal to the angle of reflection. That means if we are going through the table, suppose first angle of incidence is like if we are throw a light on an angle of 25 degree, then this angle is also when we are measuring, that is also give the 25 degree. That means in 25 degree, if the angle of incidence, then the angle of reflection is also 25 degree. Suppose if we are increasing the angle of incidence, suppose here if we are increasing and suppose we are say that it is an angle of incidence is 40 degree, then the angle of reflection is also got 40 degree. So from that activity we come to know that if the angle of incidence have some angle, any angle between 0 to 90 degree, that means it is 60 degree, 35 degree, 25 degree, that angle of incidence is equals to angle of reflection. So it is also 60 degree, 25 degree or 35 degree. So in that way we can come to know that what is the first law of reflection. The first law of reflection is the angle of incidence is always equals to the angle of reflection. This is called the first law of reflection. This is the first law of reflection. Now we will move on to the second law of reflection. Now there is a one question is also given us that what would happen if I threw the light on the mirror along the normal. To find out the answer of that question, suppose if we threw a light along the normal, then what will be the angle? The angle will remain at 180 degree, it get reflect back. That means whatever the light traces the path, it retraces again its path. So then we will represent like this. That means the incident ray after reflecting retraces its path and become the reflecting ray. That means incident ray and reflected ray are supposed to be at the same path. That means if line is traveling like from left to right, then after the reflection it will move from right to left at the same path. It retraces its same path. That is the answer of this question. If we threw a light along the normal, then it always retraces its path. Now we will move on to perform the another activity in which we will learn about that at the point of incident. At the point of incident means we will discuss this later, but before, to understand the second law of reflection, we are just extending the setup of first activity, that means 16.1 activity. Here in this picture you can see that the same setup is there. That means we required a white sheet, we require a mirror, plain mirror. We require, that is the second requirement. We require a source of light where we are using the torch. We require a comb for finding out the ray of light, and we have got this setup. Now what we are going to do, first we are just try to, what we are going to do in this activity, we are just throw the light from the source of light, that is from torch. After that, when it is passing through a comb, it is converted into a ray of light. Now as we have already learned from the first law of reflection that when the light is incident on a mirror, then it get reflected back. So you can see that when I am just drawing these arrows, this line, when I'm drawing the arrows, then this line is represented the incident ray, and after reflecting that, this ray is representing the reflecting ray. So according to the first law, this is the basic thing which the light is doing when it is incidence or strike on a mirror. So it is incident and reflected back. Now what the extra thing we are doing in this activity? The extra thing is that if you just look out carefully, then we take a scissor and we cut that paper. We take a scissor and we cut the paper from normal. You can see here there is a cut area of the paper. Now what we are going to do is we just try to cut it, and after that what we are going to do, we are just folding this paper along the table. What we are going to do, we are just trying to fold that paper along the table, and after that we are performing that activity. What we are going to do, we cut that paper. Here you can see there is a area where we cut the paper, and we are just trying to fold that paper along the table. As we folded, so what we are observing, that the light cannot traces the path of folded paper. If you are just look out the difference is when we folded that paper and when it is unfold the paper. So you can see that the ray is after reflecting, we are able to see that the light is traces the path on the paper. But as we folded, from which part we are folded along to the table, then we are not able to see the tracing path of the light. The light is traces up to that mark only where we are not folding. So what from that activity we can suggest, that the incident ray, reflected ray, and the normal at the point of incidence lie in the same plane. Same plane means, that means all the three things, that means the source of light, the reflecting surface, all should remain in the same plane. Same plane means on the same place they have to be there. Otherwise incident ray and reflected ray will not remain into the same plane. So from this activity what we conclude, that the incident ray, reflected ray, and the normal lie in the same plane. This is called the second law of reflection. What according to it suggests that the incident ray, the normal at the point of incidence, and the reflected ray all lie in a same plane. It means when the incident ray is traveled in a plane, then the reflected ray also traveled into the same plane. Same plane means at the same place. That is the second law of reflection. Now we will discuss this also. The ray of light which strikes the surface is called the incident ray. That is, it shows in that figure. This is called the incident ray. The ray which comes back after the reflection is called the reflected ray. This is the reflected ray after comes back the reflection. The perpendicular line drawn at the point of incidence is called the normal. This is the normal. This is called the 90-degree. A line drawn on the 90-degree angle at the point of incidence is called the normal. The angle between the between the normal and the incident ray is called the angle of incidence. We have already done. This is represented by this, that is the angle of incidence. This is the angle of incidence is there. Is called angle of incidence. The angle between the normal and reflected ray is called angle of reflection. The angle of incidence is always equal to the angle of reflection. That is the condition. The plane, as we have also seen in the figure also, the plane mirror, the incident ray and reflected ray are making the same angles. And if we threw a light along the normal, that means if we are throwing a light along the normal, then the light retraces its path again. That means from which path the light is coming, in the same path it will return back. That is the basic fundamental of the light of reflection of light. Laws of reflection again summarize here is that the angle of incidence is equals to the angle of reflection. The incident ray, the reflected ray and the normal at the point of incident or lie in a same plane. On a same plane means, that means the incident ray and reflected ray and normal, they all should be in a one plane. As you can see that incident ray is coming from that, and after the reflection the light is also in a same plane. So that means the incident ray, reflected ray and mirror, they all and normal, they all are in a one plane. When I'm making that squares, that means when I'm drawing this, like if you are seeing this incident ray, normal and reflected ray, they all are residing in a plane. Plane means they are at a one place. Like we have got in a room 6 walls. We have got how many walls? We have got 6. That means including the roof and floor also. So we are 4 walls and 1 roof and 1 floor is there. So wherever we are, suppose we are performing the activity on a ground floor, then the incident ray and reflected ray and normal, they should be on a ground floor. If we are performing that activity on a particular wall, then all the things, incident ray, reflected ray and normal, should remain on that wall. So it means wherever we perform the incident ray, reflected ray and light, they all are always remain in a same plane. Now we will move on to how the plane mirror works and the image formed by the plane mirror, how it is look like. To understand better, we are going to perform an activity, and that is activity 16.3. From activity 16.3, what we are going to understand, that how a image formed by a plane mirror. We have already learned about in previous classes that a plane mirror has some properties, and what are the properties, we will discuss this later. But before that, we need to understand how we are perform that activity. For this, we can understand that image formation by a plane mirror. We have already learned about that the plane mirror is represented by the symbol of like this. This is the symbol of plane mirror. That oblique lines are representing the unpolished part, and the plane lines are represented the front part. With this is, if we are indicating by 1, the 1 is represented by oblique line, that is the unpolished part, and this is the part 2, that is called the polished part, and this is the unpolished part. So you can say that this is point number 2 is the reflecting surface, and point number 1 is non-reflecting surface, or you can say that it is a polished part. Now how we can represent this, that is the plane mirror. Again, if I show to you how we are able to represent the plane mirror, we can represent, this is the symbol of plane mirror. Now what we are going to understand, how a image is formed by a plane mirror. First of all, we will take a plane mirror. This is the plane mirror. PQ is there, it is horizontally capped on the table. After that, what we are going to do, we are taking a point object. what we call, that is called the point object. Here we are taking a point object that is called point O. This is your point object. After we are taking that point object, what we are seeing, there are the two rays are coming. These are called the incident rays of this point object. The first ray, when first ray is incident on a point, then it is incident at a point of incident A. After that point of incidence, it reflected back and it represented by point B. That means first ray OA is incident ray, and for first ray the refracted ray is OB. That means OA is incident ray and OB is the reflected ray for first ray. If we are say that this is the first ray and this is the second ray, then OA is incident ray and AB is the reflected ray for first ray, and this is the normal of first ray. Now if you are going through the second ray, then you can see that second ray is incident at a point of incident C, that is OC. OC is the incident ray, and this is the normal for second ray, and it is reflected back and it is represented by CD. This is represented by CD. So OC is the second incident ray, and after the reflection it becomes CD. Now what we are going to do, we are just extended the lines behind the mirror in drawing. As we are just extended the lines behind the mirror from point of incidence A and point of incidence C, then what we are getting, we are getting an intersection point I. And that intersection point I is nothing but it is the image of the point object into the mirror. That is the image of the point object into the mirror. And if we are comparing the distance from object to the mirror and mirror to the image, then it will remain same. That is the first property of the plane mirror, is that plane mirror is always from the virtual image. That means an image which cannot be taken on a screen, that is known to be the virtual image, and it is always formed at the same distance. That means the distance between the object and the mirror and the distance between the image and the mirror are remain same. That is the second property. So that is the image formation by the plane mirror. And after that you can see that is also performed in this activity. Here you can see a point, we have taken a candle of light, and if we try to see that into the mirror, then it can be seen into the inside the mirror. That means the virtual image. We can say that we can form a virtual image in it. That is the real image and that is the virtual image, and distance between object and plane mirror and object plane mirror and image and plane mirror, they all remain same. As you can see that the distance between X and here is also the distances remain same. Here you can see also another example, like if we are just standing in front of a mirror, then we can see that the distance between object and the mirror and distance between image and the mirror is remain same. And in third condition also that is the same thing if we are just look out the R side. So what are the properties of plane mirror have? The plane mirror have, the first property is image is erect. Erect means, that means vertically straight. That means whenever we see, then it is always vertically straight. The image is same size. That means whatever the size of the object, the size of image is same. The image is at the same distance from the mirror as the object is in front of it. That means the distance, that means object to the mirror and image to the mirror is always remain same. The image is virtual. That means it cannot be obtained on a screen. The image is literally inverted. What is the mean of the literally inverted? If you are just going through the third picture of the slide, then you can find, if you are just raise your, this is the representation of your left hand and it is appeared to be right. The object here, what we are raising our left hand in front of the mirror, and the image which is formed inside the virtual image which is formed inside the plane mirror, it seems like a right hand side. So that is called the laterally inverted. That means the right appeared to be left and left is appeared to be right. That is the another property of a plane mirror. So these are the property of plane mirror, and this laterally inverted is also called the lateral inversion, in which the left of the object appeared to the right and the right is appeared to the on the left. This is known to be the lateral inversion. This is the property of plane mirror. Now what we need to do, we are going to understand that what is the regular and irregular or diffused reflection. When the rays are incident on a irregular surface, as you can see into that picture, this is your irregular surface, and the ray of light are incident on it. Then after the reflection, they are moved into the different direction, but at the point of incident, we should remember here it, at the point of incidence, the law of reflection is always follow. That means at any point of incidence, if we are comparing the laws of reflection, that it always follow. So but if we are look at out the surface, if the surface is uneven, irregular, it is not smooth and polished, then the reflection takes place by that kind of surfaces. That is known to be the irregular or diffused reflection. That is known to be the irregular or diffused reflection. When all the parallel rays reflected from a rough or irregular surface are not parallel, the reflection is known as a diffused or irregular reflection. That is the definition of regular or irregular or diffuse reflection. On the other hand, if the reflection a smooth surface like that a mirror, then it is called a regular reflection. That means if you are saying this is the regular reflection, that means rays are coming and they are reflected back by the same angle and they are forming the same angle and their surface is polished. That means they are having a polished surface. On the other hand, in irregular reflection or diffuse reflection, they have not got the polished surface, they have got the uneven or irregular surfaces. When parallel rays of light falls on a rough surface, the refracted rays are not parallel. This is called the diffuse or irregular reflection. Diffuse reflection does not form images of object. That is also another important thing, is that diffuse reflection does not form any images. On the other hand, the regular reflection forms the images of object. But we should also very clear on that point that the laws of reflection are always follow in both the reflections. Either it is a regular reflection or irregular reflection. This is your picture of regular reflection, and this is the regular reflection, and this is your irregular reflection. I hope you understand the concept which we have discussed in this video. Thank you very much.